Hello and welcome to this new video on data analysis using Pandas. Pandas is a library that we use frequently in many of our projects, and in this video we will cover in a few slides the key features functions of Pandas. Pandas is a powerful and flexible data manipulation library for Python. It provides data structures like series and data frames that makes data analysis and manipulation easy and efficient. Two of its primary data structures are series and data frame. Series are primarily one-dimensional. These can hold mixed data types, but these are generally designed for homogeneous data. When mixed data types are present, the data type is cast to object. It is a label array, which means each element in a series has a label or index which can be used to access individual elements. Data frames, on the other hand, are two-dimensional. These are designed to handle heterogeneous data across columns. It is a tabular structure with rows and columns, and both rows and columns have labels or indices. Next, let's try to load a CSV data as Pandas data frame and look at some key functionality. Our example CSV data has 5 columns: name, age, salary, joining date, and the department where the employee belongs to. The data type are heterogeneous as name is string, age is integer, salary can be integer or float, joining date is a date, and department is a string. To load the CSV file, we can use the pandas read underscore CSV function. It has so many arguments, as you can see, uh, but in the code snippet on the right, you could see that we only need to provide only the file name, and Panda will still be able to read the file. Let's have a look at the code snippet to the right. In cell 1, we are importing pandas library as PD. In cell 2, we specify the file path, which in this case is a file name by test underscore data.csv, and which is located in the current directory. In cell 3, we read the CSV file as pandas data frame. In cell 4, we check the data types pandas assigned to each column in the CSV file. As we can see, name, join date, department are all loaded as object type, whereas age and salary are loaded as integers. Next, we will see how we can load the columns in their correct formatting. In cell 5, we list the column names in our data frame. In cell 6, we specify the types of columns and create a dictionary structure for all the columns except join date, which we will use in the next cell as parse dates column. In cell 8, we now specify data types as dtype and provide the date column for the date parsing. This loads the data in correct format, and we can see some data rows as in cell 9. Let's now try to learn some pandas operation by solving a few problems. In problem number 1, we want to find the number of employees in our data frame who are older than 35 years. In cell 10, we apply a greater than 35 filter on the age column and then use the count method to get the number of employees. We can see that there are 2 employees older than 35 years. In cell 11, we apply the same filter and display the entire row data to see the employee information. And we can see Frank and Jack are the 2 employees who are older than 35 years. In problem 2, let's say we want the employees to be happy, so we are giving each employee a 5% raise. In cell 12, we use the apply method on the salary column and use a lambda function to update the current salary by 5%. As you can see, we are not saving these in a new column, but updating the values in the existing column. In cell 13, we again use head method to display the top 3 rows and the happy employees with higher salaries. In problem 3, we want to list the highest paid employees in each department. In cell 14, we first find the maximum salary per department using the group by and the aggregate methods. We group by the department column first and then in aggregate calculate the maximum value on salary column and then use reset index to flatten the multi-level index. We then use the merge method to merge the above result with the original data frame on department and salary columns to get the full details of the employees. In this problem, we want to add a new employee to the data frame. In cell 15, we have a new employee, Michael, and we store all this information as a dictionary. In cell 16, we use Pandas concat method to append the new employee to the existing data frame. In cell 17, we use the tail method to show the bottom 5 rows in our data frame, and we can see Michael is successfully entered into data frame on row 10. In this problem, let's say a new employee joins, but HR initially failed to provide the salary info. Later, HR suggests that her salary is the average of all salaries in IT department. So our task is to add this employee to our current data frame. In cell 18, we create the employee as before, and instead of the salary, we provide NaN from the NumPy library, which we import above. Then we use Pandas concat method to append the new employee to the existing data frame, and we can see in the data frame the employee Janice has no salary specified. Instead, we see NaN, which is not a number. In cell 19, we use the fillNA method to assign Janice her salary, which is the average salary of all IT employees. And in cell 20, we can see Janice now earns $87,587.5 annually. This concludes our Pandas tutorial. There is so much more we can do with Pandas. I hope you liked it. See you in the next video.